Here we go. I'm going to turn off my front lights so everybody can see. Sound. Yesterday we did the hearing test. How do you guys do? Not so bad. Not too bad.
I'm 4 of 24.
Same. Same. All right, sound. What is sound? So let's check it out. Properties of sound. Longitudinal wave. What is a longitudinal wave? What's a longitudinal wave? What happens is it goes back and forth, right? So sound goes back and forth. You guys see that? It goes back and forth. Okay? Back and forth. Okay? Longitudinal. Particles vibrate parallel to the wave direction. All right? Sound goes through a medium. Goes through solid, liquid, gas, right? Most of the time we hear it through liquid. Yeah, most of the time we hear it through a gas, correct? Okay. Now, a moving object, such as a drum, causes the medium around it to start vibrating. Okay? This is actually going to be part of, well, we're not using a drum, we're using tuning forks, but we're going to do that tomorrow. It's going to cause a lot of vibration. Okay. Feel like we're good there. Mediums. Okay. So we talked through solid, liquid, gas. Can you hear through solid? Like if I stood on the outside of that door, could you guys hear me if I yelled really loud?
Yes.
Now, could you hear me better if I talked in a higher frequency or a lower frequency? Ooh, got a little difference. Going through a door, the higher the frequency, the more likely you would be able to hear it. The higher the frequency. Okay. Sound will travel faster in warm air than cold air, but it travels fastest in solids. What? So when I talk like this, it's traveling slower than what I would try to do in a door? Why? So it travels fast through a door? Then why don't you hear better through a door?
Oh no. Because it's solid. It's like canceling out some of the
Sound waves are cut off. Now, let's say here's the door. Right? It's a solid door, so all the particles are right next to each other. Let's zoom in. There's all the particles. Okay, just real close. They're all close together. Now, when one hits one side, the other side kind of hits right away, right? It's kind of like my Newton's cradle. Okay? I like the Newton's cradle. Whoop. When one side hits it, the other side bounces, right? So they travel real fast. Okay. So let's try this out. We need a book. Okay? We need a book. So I'll pass out books here. Read the directions as I pass out the book. Oh, one too many. There we go. Or if you guys just want to use a binder, but books work a little better. Okay? There we go, sir. Solid on it. You're welcome. Solid on the outside, but the liquid would vibrate on the inside. Okay. Should be good.
I'm getting.
All right.
Now high five.
You're learning chemistry today.
Look at her elbows.
You got physical science. You're learning AP physics.
I mean, I don't know, high five.
There we go. You need a book?
No, I got it.
All right, we're good to go.
You got some.
All right. So
Now if you look at people's elbows. And
now hold the book against your ear, or place your ear. Tap against the book.
Oh.
Now tap it with your fingernail. Which one sounds with a higher frequency? Your hand or fingernail? Your fingernail. Why though? Wouldn't it be the same? No, they're made out of different substances. Well, your skin to your fingernail. All right. Now, move your hand away from the book and tap. Why does it sound differently? Anybody got an answer? Devin?
It's not only the solid, it's walking the noise is like not directly close to it's like some there's like the ears have the sound like it has to the ear.
Awesome. So what we have in this example is when it's right next to your ear, this is going to be a rough drawing. Your ear is, I don't even know. Your ear is right there. So the particle from your hand to your ear, you hear it pretty good, right? You hear it really well. So your ear is at the end of the solid, and you hear it really well. But when it's farther away, you don't hear it as well, right? Going through the solid. Okay. They travel through different mediums. All right. Intensity. This is the last thing. Intensity. Relative intensity is how loud a sound appears when compared to the quietest sound a person can hear. So how loud a sound is compared to the quietest somebody can hear. Okay? It's measured in decibels. Okay? Quietest is 0. Max for permanent ear damage is 140. That's like if somebody's sitting right next to a cannon or something like that. You might get up to 140. Okay? Now, here's a chart. Okay? Here's a chart. And it's very, very interesting to look at. All right? A ticking watch is about 20. That's not bad. A mower is 90. Do we get some ear damage if we don't protect our ears? Over time, you probably would. You probably would. Headphones go up to 100 and 110 if you blast them all the way. You get ear damage. Pretty crazy. Now, there was this study that actually, I forget the ages, probably like 8 to 10-year-olds, right? They're all about maybe this height, right? What happened was they go to like a public restroom and they have those hand dryers, right? The air dryers. Have you guys had those? They're so loud. Some of them are really loud. But if you're at that height of the air dryer, kids have permanent ear damage from those. They're so loud. Right? That's pretty crazy. Yeah.
Yeah, on your phone, like, when you're listening from earbuds, it tells you, like,
Oh, it tells you decibels?
yeah, it tells you, like, it's like around, like, 0.
Yeah. Wow, okay. Okay. All right. Intensity and pitch. So yesterday we talked about different pitches. The higher the pitch, the higher the frequency. All right? So what I want you guys to do is take a ruler. I'll give you guys rulers. Yeah, we'll try one. Stay with it. I'll take that. There you go.
Tiny.
All right, read the directions, try it out. No.
That blue one. I want to pop. Hold on.
There you go. Does plastic work?
Okay.
All right. You can hear some. Sounds pretty cool. All right. Guys, don't snap it so hard that it breaks.
You gotta hold it more out, and I wanna hold it more out.
All right. So, which one has a higher pitch?
Yeah.
The farther it is on the desk or the farther away from the desk it is? Farther away from the desk has a higher pitch, which means it has a higher frequency. Pretty interesting. Pretty interesting. All right. And then we already watched that video, right? Cool. Any questions, guys? Tomorrow, what we're going to analyze is, have you guys ever seen, like, people tap the glasses and try to make sounds, different sounds with different pitches of water? We're going to do that tomorrow. We're going to check out some tuning forks, okay? And we'll have a normal day tomorrow. It'll feel good. So, guys, you only have probably about a minute left.
Nothing's normal.
Nothing's normal?
Every day can be a day. Maybe.
Fair enough. All right, so, guys, leave everything at your desks. That would actually be perfect. All right. All right. I'll post that video here.
I have it right now.